Saying them all. So, unless you want to get a feel for it, I'm gonna improve it. Oh, it's a little annoying because I wanted to see what it looked like on the overfit data just to see visually how it's looking, but okay. I'm just gonna turn off my AWS server until I need to start training it again because it costs a lot of money to have it running. Okay. So the training was pretty good. It still has a little bit of problems kind of filling in the whole area. Um, and a little bit of problems, I think, semantically. By that I mean like telling these are shutters, these are siding, this is brick. So it's like not super sure what's what. Sigma anything did a better job of that, but my model does seem to do a better job at minimum of not producing those round edges, which is to me is important. So I'm just trying to think. How I could improve here. Okay. So I have three main questions that I want answered. I think it's at least three. First one is why the hell am I multiplying the prompt embedding by the upscale embedding? This is a I've already like done the cross attention from the image to the what I'm calling the prompt embedding. I've already done cross attention both ways. So from I don't know exactly what that means, but in my head it's like I'm trying to think about what an attention. I guess for now I'm just thinking about it like any other layer in a neural network. So I'm thinking about it almost like as an MLP layer. And maybe it's not the right way to think about it. But I don't know how else to think about it for now. So I'm thinking about it as an MLP layer. So I do In my head, I have like at least call it a layer between the that basically combines the my prompt embedding with my image embedding. So I don't know why the hell I need this. Um, that's what segment anything does. They're multiplying the upscaled embedding by the prompt embedding. To me, that's very weird. I don't understand the intent behind it, and it's confusing. So I'm going to see if we can not do that and how things turn out. I mean, I'm assuming they have a very powerful, good reason for doing it, but I don't understand what it is. So um, it gets the one thing it does is it gets the thing in the shape, which basically a one channel image. But who cares about that? There's different ways I could reshape it. So there's got to be some reason they're doing that. That's good. So that's one thing. See, test. So one, test how we do without multiplying by the prompt embedding. The other question I have is, let's see. It's not really a question, but I think we need to rework this transformer. These position embeddings are being used by this transformer with the tokens. Um, and that doesn't make any sense because these tokens don't have, they're just classification tokens. They're not points. So they shouldn't have anything to do with that position embedding. So I just want to remove unneeded stuff from transformer. And also in that vein, we also need to, this is another question. We need to, uh, can we do attention layers at different resolutions, basically, with the same token? Or are we going to need a different token for every resolution? Because right now I'm just doing this attention layer at the end. And to me, it feels like it would work much better if we did some sort of attention layer that was conditioned on the prompt encoding at every uh, layer of the decoder, because we're upsampling. So we're upsampling. It's basically a Unet. And so I could just start with those three questions. I have more questions too. The other big question I have that I want to figure out is, I'll just start with those questions for now. It's enough questions. Enough questions. All right, so I gotta crank up my AWS thing again. I turned it off, but now I need to answer a question. All right, I'm cranking it up. So we're going to answer the first question. Let's write these questions down. What? Do we need to multiply the token by the embedding after tension layer? So we will save it this time. So what I'm going to do is instead of that multiplication, I'm just going to make this patch embed go from 64 channels because it's currently at 64 channels. So it was being, this is the in channels, this is how many it thinks are coming in, but as we unbed it, now it becomes the out channels. 1. So it's as simple as that actually. We just need to do convolutional to put that one channel out rather than 64. Okay. So we'll just see how this does. If this does the same, and the ballpark are the same, then I don't know. Yeah, I don't really signal anything else up there. What other questions do I have? Baby's crying. This transformer. Okay, let's talk about this transformer. I need to simplify it. Or do I need to simplify it? Because I might want to. Let's look at it. Let's look at it. Most confusing transformers I've ever seen. But I've only seen like 5, so. Maybe I should leave the positional coding. I don't know. This changes it back into the patches. Same thing. Change these into patches. Okay. Why did I think that? The image PE is the positional. We've already added the positional encoding to the image prior to. We need to do that. Query starts out as the point embedding. The keys start out as the image embedding. Query PE is always the point embedding. That to me is weird. I don't understand in what sense that's a positional encoding. I don't know if it's going to hurt anything. HP, so that seems fine. Layers. Okay. Balancing pull attention. Cross attention of dense inputs to sparse inputs. So I like all that. Queries, keys, query PE. That's the only thing that's a little weird to me. Don't understand that query PE. Positional encodings on that. Craziness. I've already added the positional encoding once, but I guess I could just add it in twice. Point 6. Let me see, where were we with this? Down to 0.4. If it doesn't work at all, that would be telling. Let's see. Okay, so here's what I'm thinking about doing. It if I could just, I could continue to rescale. Or I could just use a different class token. Token need to be, does the token need to be the same? I think it does. Really? I'll do that later.